Worksheet 12D, the stress block shown similar to or the same at 12A, B, and C, and using the Mohr circle to determine the principal stresses, the maximum shear stress, and show the orientation of the planes on which they act. So basically, principal stresses is asking in worksheet 12A and maximum shear stress 12B. So this problem basically combine 12A and 12B, but using graphical method, in this case Mohr circle. What we did in 12A, B, and C are analytical method. We apply the equation directly, and regardless of if we apply the equation, then we have sigma x in this case is negative 1400 psi, and then we have sigma y equal to plus 1000 psi, and we have tau xy equal to negative 500 psi. So for equation, let me write down here, when we use equation, whenever you use equation, we have that, because if we use the graph later on, when the Mohr circle, go back to review your note, Mohr circle, the side convention, normal stress, the same tension, positive, compression, negative. Shear stress, that a little bit different. It divided by, if the shear stress create a clockwise rotation for the block, then it positive. It counterclockwise rotation for the block, it will be negative. And then for the Mohr circle, as a circle, we need to find out what is the center, where is the center. So in this case, the center for x will be sigma average, and the vertical it will be 0, and the radius of Mohr circle equal to the root square as shown in here, and it actually that root square equal to tau max. So first we need to find out center and the radius before we draw the Mohr circle, and that we use equation. So apply in here, we have the center, so we have AB, so we have sigma average, which is A, equal to sigma x minus sigma y over 2, sigma average plus sigma y over 2, so we have negative 1400 plus average over 2, so it will be negative 200 psi. So the center of this circle is, as you can see, so as you can see, the Mohr circle center, the center width is AB, it equal to sigma average 0, and in this case negative 200 psi. That's what you have for the center of the Mohr circle. The next one, we need to find out the radius, and the radius equal to tau max. So we have to find out tau max equal to square root sigma x minus sigma y over 2 square plus tau xy square, and plug the number in, and we also have this number before. It's 1300 if you recall, so we have it negative 14 negative 1000 divided by 2 square plus tau. We use equation, so it's negative square, and that actually the radius. So as you can see, the radius A of the Mohr circle equal to tau max equal to that number is 1300 psi. 1300 psi. So we already have the Mohr circle centers and the radius. Then go ahead to draw the circle. And for this problem with Mohr circle, we need to have a protractor and we need to have a compass. So we have it here. Let's show that in the grid. So if you do the homework or you do your exam, then you better to have a engineering paper with have the grid in here, so that you can be able to draw it correctly with the scale, etc. So with here we can make the axis for the sigma axis for the Mohr circle. Actually that is at the x-axis, so that is the sigma axis. And units psi, and the vertical axis is actually tau. So we have the vertical axis. Of course you can use your ruler to make it nicer, like that I did in here. So this is tau, and it also psi. So that is the axis. We want to have the center, locate the center, and let's see, you can make the scale here. We have the radius is 13 psi and 200. So let it one is represent for 1 square represent for 200. So 200, 400, 600, 800, 1000. That's perfect. So each square here I make it 200. So the center is negative 200, 0. So you have the center is here, negative 200, 0. So that actually this is sigma average 0. So write down sigma average 0, the center of the circle, and the radius is the tau max, which is 1300 psi. So what is 13? Go to the left. 200, 200, another 200. So 4, 6, 8, 1000, 12, 13. And then you have here 200, 400, 600, 800, 1000, 12, 13. So that is radius. Similar to go up on the scale here. 200, 400, 600, 800, 1000, 12, 1000, 12, and 1300. So we have the center and the point there. That another point. This is the point. This is the point. And similarly, we have the 1, 2, 3, 4, 5, 6. The middle one there. It will be the radius. So you have the center, you use your compass. I try to use my hand to make it as good as possible, but in indoors you can use your compass to make sure it look nice for here. So let's try our best here with the circle. Try bit here with the circle with hand, or in the, if you use your note, you can use one note. It can be use handwriting to circle with your OneNote. It automatically transfer to OneNote. It look not good in this side. So we can look perfect circle. So we have everything, and then you can see sigma average each scale stand for 200. So you can have that. Let's put down the number here. Put down the number, and you can see this is 200, and then another 13. So you can see that if that is sigma 2 negative 1500, negative 1500, and as you recall, that is the principal stress sigma 2 with that number sigma 2. And of course, this portion we have sigma 1. If you recall, sigma 1 is plus 1100 psi. That actually the intersection of the circle with the horizontal axis sigma. So this is sigma 1. So as you can see, the first intersection on the right, it will be sigma 1. The circle intersection with the sigma axis on the left, it will be sigma 2. So that one is sigma 1 is positive 1100 psi. And as you can see, with that exactly the same what we did in worksheet 12A. So that is the first principal stresses. And of course, the orientation, we will talk about that a little bit later. Tau max is, as you can see, the tau is the vertical. So the tau max actually here, it got there. Tau max. This point is tau max, right? Tau max. When you make a on this side, it will be 13. So we have that equal to 13 psi. So we already have the unit, so we don't need to put down here for the circle. For the Mohr circle here, we already put in the axis psi already. Otherwise, you can say psi, and also here psi here. psi.